Now I'm presenting the robot control dashboard. So this dashboard helps us to connect with the robot and give us the HMI for any operator on the factory. This web HMI is the entry point of the robot for the end users. It presents all the vital information coming directly from the robot and just presenting over the web HMI, and it also facilitates for the end user or operators to assign the goal or mission. Right now it's in very basic form, connecting the one robot in live scenario and transmitting all the live data of the current position and the goal position and the path planned between all them. It is represented, but it is now being extended to the advanced HMI as a fleet manager. I would also like to show you some of the glimpse for that. This under development version 2 of control dashboard offers clean UI and the support for multiple robot. The technology behind the communication of robot is MQTT. All the robots connect to the one backend over MQTT. Fast API based backend is adopted to support the upcoming integrations with WMS or ERP system. Talking about the key navigation aspects, in current scenario, robot is trying to avoid an dynamic obstacle. Looking at the map, we can see this obstacle which kept in the pathway of the robot was not initially present while mapping. So in the real time, it processes that obstacle and tries to avoid that. And the margins between the obstacle and the robot depends on your configuration. Essentially, these are the configuration which we need to set when we are deploying any on new environment. In next scenario, person is acting as a dynamic obstacle coming in front of the robot. So robot stops there and replanned its path. Package implemented for obstacle avoidance and dynamic path planning depends on the live sensor data and noise. And once these are improved, then resolution of obstacle avoidance and path planning also gets improved. In current scenario, the robot did not get hit with any of the dynamic obstacle. That is the performance right now we have. So that completes the demo of live run of the robot on real factory scenarios. The integration between the hardware, software and the IT systems are running in sync. Okay, now presenting some of the things about the robot we mentioned over our website. So some 3D design to look over it and a few of the testing videos of how navigation looks and feel on the drivetrain. Few features like I covered in the video: autonomous path planning, robotic fleet and obstacle avoidance. Some of the key robot we developed as part of the development process to test it out. And taking to the software side, uh, in through the privately owned GitHub, we are hosting all our code in central place, and this cyborg fleet, this repo contains the current code with which our robot is running. And essentially we have developed multiple packages which goes together and powers a full robot.